that. We're going to have in this one, we're going to have molarity, gas laws, PV equals nRT, and stoichiometry. The central concept we need to get to is the number of moles. Okay? We get to moles, we're good, because we can do stoichiometry from that. So let's go ahead and do number one. Now these are real nice because they're already balanced. And I will make sure that it's on this. Okay? You need to follow along as I go through the sentence. Make it a little larger. Okay, so if I look at number one, it says 18 grams of ethane. Well, if I'm looking through here, we know that that's oxygen, carbon dioxide, water, so that's got to be ethane. Okay? Process of elimination. Now I have 18 grams of this, and then I have a pressure of my oxygen as 2,225 mmHg, and 252 milliliters of space, and 219 degrees on my Celsius for temperature. And it says how many grams of CO2 are going to be produced. So that's what it's kind of on the setup. And again, not doing anything that special. I'm just going ahead and putting the numbers in. Any questions so far? They're kind of straightforward. Basically what I want to do is I'm going to go from here to here and from here to here. You look for the one you're trying to find. Going from here to here. How would I do that? That's a S word, right? Stoichiometry. So I'll do that one first. We go 18 grams of this. So if we have enough room here. What's going to go on the bottom? Grams. C2H8. Oops, let's lower this down a little bit. C2H8. And we all know how to do a mass, but what hasn't made the appearance yet? The mole. Isn't that the big one? We might need to have some space here. I'll move this one up here. Okay, so that's the big one. And then we have to do a mass for this bottom one, right? Right? So the mass of that is 32. This would be 24. 2 times 12, 24. And then 8 hydrogens. Now 24 plus 8 is 32. And we're going to continue moving on. We've already taken care of this part. If I follow pattern, what's going to go on the bottom on the next step? Mole. What is the step again? What do we call it? Momo box. That means I got to put moles at the top. How many moles do, which one am I trying to find on the moles? CO2. What I'm trying to find. Okay. How many moles of this? One. Right? And how many moles of CO2? 2. Keep going, because I got to go to grams. What's going to go on the bottom on the next step? Mole. CO2. And now I can do grams of CO2, right? Again, shortest amount of steps to get where you're going. Which one's the big one between the two? Mole. And then the mass of this is 44 grams. Okay? 12 plus 32. Now we can go ahead and calculate it. We know that this cancels out. I'm in grams. Looks familiar, right? And it keeps showing up all the time. So if we calculate it, we're going to have 18 times 2 times 44 divided by 32. So my number ends up as 49.5 grams. Are we assured that that is the correct answer? Yes or no? No. This is a limiting excess reactant problem. I got to take care of this part here with all those gas law parts. Questions? I am recording it, by the way. So, I'm going to go ahead and erase this part, because I got to take some care of these things, getting them in the correct units. Okay? Okay? Apologize for that, but again, these guys take some space. Sheet of paper when you're doing these. Okay, I'm going to take care of these parts here. Kind of scrunched up. I'll move this guy back down here. Now I have to convert stuff. We didn't really cover it a whole lot as far as converting gas units. So we got to remember we have a standard for MMHG. Well, I'll put them down here. And 101.325. APA. Those are all the standards. If you're going to shorten your steps, which means not having to write everything out, usually you have to divide to get it into your formula. This is my formula for this gas law. It is ideal gas law, which is what we're going to use all the time. That's how this works. R is 0.0821, right? Now I have to take care of this unit. I divide it by its standard. So we go divided by 760. And where'd my calculator go? So 2225 divided by 760. And we got, for this one here, 2.93. That is the number I can use because now it is converted to atmospheres. Okay? So when I see MMHG, just divide by 760. That gets it in your formula. 2.93. What about my volume? It says 252 milliliters. It's supposed to be in liters. So that one doesn't work. You guys remember the number we divide by? 1,000. We're doing the molarity, right? I end up with 0.252 liters, which I have to put here. We're always going to be solving for moles. We like the mole. So we're going to solve for moles on this. What about my temperature? Does that work? We don't want it in Celsius, do we? What do we add? What's that number? You guys remember? Man, it's good that we're going through this again. Remember 273 Kelvin. And then we're going to add this one up. Ooh. Let's do this quick. Yeah. 219 plus 273, 492, which goes here. We have to do all of this in order to figure out what my correct answer is for the CO2. So, we're recording. .738 and .0821 times 492 equals 40.39, and we just divide. And then all I have to do is divide to get my moles. All that work just to get the moles, which we've done before. And I've got 0.018 moles. So I got my moles. Questions on that part? Again, we just want to get everything to moles. If it's not, get it to moles. Okay, so I'm going to go ahead and erase this part. Again, it's going to be on video. Now I can use that mole for this one here. So I'm going to just erase this part. Again, takes a little bit of work. I'm going to keep this number down here. Now I can use the 0.018 moles, and I can do stoichiometry now. Again, moral of the story, get everything to moles. What's going to go on the bottom? Moles. O2, right? What do we call that? Mole box. And I'm going to go over from here to here because it's my question mark. How many moles of O2 do I have? 4. How many moles of CO2? 2. What goes on the bottom? Mole of CO2. Again, I'm going back to the grams. You already have the mass of the grams. Which one's the big one? The mole. And then my mass of CO2, 44 grams. Let's get from behind the Chromebook so you're paying attention. And divided by 4. And this one comes out as 0.396 grams. Which one's the correct answer? Biggest one or smallest one? Smallest one. The reason is they can both produce 0.396 grams. They both cannot produce 49.5 grams, which means this one will never happen. And of course we know now what the limiting reactant is. Right, Matthew? Which one's my limiting reactant? Is it this one or this one? That's CO2. A lot of work just for one answer, right? Some of them are not that long. Some of them are, but that's okay. Questions? Did I do something that was difficult? No, it's just a lot of steps. Matthew, that wasn't that tough. Oh, no it wasn't. After you do a few of them, it's not a problem. Just imagine having to show it. That's not the easy part. Okay, so we're going to go to another one. Again, moral of the story is we have to get the moles. We also have the molarity formula, which also has moles. So we got to go to moles on that. We'll go number 2. Are we okay over there, Milton? Stand up and stretch if you have to. Can't be that boring. Just math. Not to the usual, but we got this one. This one's a little shorter, a little easier. Again, I kind of write these out again. So I got 3 timing on the bell, and you'll notice I'll just put everything where they belong. Nothing that difficult, nothing that surprising. And I'm figuring out how many moles of this are produced. Not dealing with H2. Again, all I did was write the numbers down. This is the part of the molarity formula, which again has moles. I'm just going to put that as a line. We do have to find it. So first of all, the formula, right? Molarity equals moles over liters. So if I'm going to be finding moles, let's put the Chrome notebooks down, please. What am I going to do to those numbers? Add, subtract, multiply, divide. But if I wrote this, what would I do? Cross multiply?
Oh.
Okay.